Now, this lesson is a little bit of a break in that we're not dealing with surface area. So we're not dealing with some of those formulas we have to deal with. We're still looking at the same types of shapes like prisms, rectangular and triangular prisms, and cylinders. We're just finding the volume. So we're not looking at the surface, we're looking at how much these things can hold in volume. So basically we're using one formula, but it adjusts depending on the shape of the prism we're looking at. That formula is capital V, volume, equals capital B, which is area of the base times the height. Okay, it's very simple. Area of the base always changes depending on the shape of the prism. Okay, so the volume of the cylinder, it's still area of the base times the height, but since the base is a circle, it's power squared. Okay, so it's all the same formula today, but capital B changes depending on what we're looking at. Let's look at the first set of problems. Okay, so we're going to find the volume, and again, we're just finding how much this box holds. So the first step is to find area of the base. So the base, as you notice, is a rectangle. Okay, and to find the area of that rectangle, it's length times width, 12 times 6. Then you multiply, see, V equals capital BH. Capital B is 12 times 6, that's area of the base. So V equals 12 times 6. Then you multiply it by the height. Okay, B, capital B, 12 times 6, height is 8. So basically what you're doing is multiplying the length times the width times the height in any rectangular prism, which is kind of the way we learned it when we were in elementary school. Length times width times height, volume. Okay, so we need to multiply these out. We get 12 times 6 times 8. That gives us 576. And because we're multiplying, 576, because we're multiplying feet times feet times feet, that is feet cubed, not feet squared, like we were doing with surface area. Feet cubed. Anytime you're dealing with volume, you're dealing with cubic units. Okay, again, V equals capital B, H, again, essentially that's length times width times height, which is 18 times 12. That is the area of this base. Then the height of the prism is 4. Okay, so 18 times 12 times 4 gives us 864 centimeters cubed. Okay, this one, again, V equals capital B, H. That is length times width times height, 4 times 5. That's the area of the base, capital B. That is 4 times 5 times 4. Okay, 20 times 4 is 80. 80 yards cubed. Okay, keep going. Now let's look at these two triangular prisms. We're still using the same formula, V equals capital B, H. Okay, now we know this is H from the surface area problems that we had. It's the height of the prism because we're considering the triangle the base, and if I set it on its base, this is actually the height, but it's sitting on its side. Okay, so capital B is area of the base. The base is a triangle. It's this triangle right here. I just need to find the area of that triangle, which is pretty easy. It's base times height divided by 2. So I've got 3 times 3 divided by 2. Well, that's 9 divided by 2, which is 4.5. Then the height of the structure is 5. Okay, multiply 4.5 times 5, and you get 22.5, and that's meters cubed. Okay, again, area of the base was the area of the triangle. The height is right here, and that's it. We're not using this information back here. Okay, just 3 things we're multiplying. Next triangle. Now, because this is a right triangle, this is the height. But if I have a triangle that's not a right triangle, the height has to be drawn in so we can know exactly what the height is. This is the height because this is perpendicular to the base. This is the height because this line is perpendicular to the base. These lines are not, so they have to draw the height in if that's confusing to you. Okay, but I'm finding the area of this triangle. So it's base times height divided by 2. That's 3 times 4 divided by 2. That's going to be 6. Okay, times the height of the structure is 3. That equals volume, which equals 18, and it's feet cubed. Okay, that's it. There's our two triangular prisms. Capital B, in this case, is 1/2 times the base times the height of the triangle. Okay, and then the height, H, is the height of the prism. Okay, moving on. I'm using V equals capital BH, but in this case, since it's a cylinder, that's the same as pi r squared h. Area of the base times the height. Area of the circle is pi r squared. Height is the height of the cylinder. Okay, so let's plug these numbers in and get what we get. I need the radius. I'm given the diameter. So the radius is 1.25. So I've got 3.14 times 1.25 squared times 5. Okay, so all we have to do is, let's do 1.25 squared first, which is 1.5625, times pi times 5. I get 24.5. We're going to round it to 25. And we're going to say inches cubed, cubic inches. Okay, again, area of the base times the height. Here's the base, the circle. V equals pi r squared. Well, this is the diameter, so I need r, which is 6. 6 squared is 36. The height of the cylinder is right here, which is 17. Multiply. Okay, 3.14 times 36 times 17. That equals, big number, 1,921.68, and I'm going to round that up. Let's go 1922. And that will be feet cubed. And that is it. Okay, that's volumes of cylinders. Let's move to the greenhouse, and notice I did something wrong again. This is probably from fatigue when I was doing this. I should have proofed it, but I didn't. Find the volume of the greenhouse, not of the greenhouse. Anyway, you get the picture, literally and figuratively here. We're going to find the volume of this greenhouse, so we're just finding out how much it would hold. Let's just say we have a hole in the top, we fill it full of water, and it can hold it. How much water could it hold? That's what we're looking at. So this thing has two structures, a rectangular prism and half of a cylinder. Well, so we have to find both and then add them together. So volume equals capital BH for the rectangular prism. Capital B is the area of the base, which is 25 times 12 times the height. So length times width times height. 8 times 12 times 25. Okay, 8 times 12 times 25, 2400. Okay. Next, what we're going to do is find the cylinder. Well, it's 2400 feet cubed. Okay, let's find the cylinder. Okay, this is a radius of 5 feet, so it's V equals capital BH. This is capital B would be pi r squared, so it's 3.14 times 5 squared, which is 25, times the height of the cylinder, which is this length right here, which is 20, and you can't see that in there, which is 25. Take my word for it. This is 25, this is 25. So 25 times 25, we should know that, and then we multiply that by 3.14, and we get 1,962.5. But this is half of a cylinder, so we have to divide our answer in half because we've only got half of the volume. Divided by 2, we're going to round it to the nearest whole number, 981. I'm going with 981 feet cubed. Now, I've got the bottom part, I've got the top part, so if I add those two things together, I should get a good answer for this. We're going to go with 3,381 feet cubed. Okay, notice with volume, I did not have to worry with the fact that this thing had no top here. Okay, with surface area, we were finding the different surfaces. I did not have to account for the fact this thing had no top for volume. But with surface area, I had to, because of my formula, I had to realize that this had no top. And so we had to deal with that, or no bottom actually either. So we had to deal with that with our surface area problem. Okay, but this volume's a lot easier. Area of the base times the height. Always remember that. Area of the base changes depending on the shape. Cylinder, triangular prisms, and rectangular prisms. That's all we're looking at with these last two sections that we've done.